Did you do this with the normal logarithm, or does it have to be natural log?
Oh, if I can do it with any log, but then I will have to divide by the natural log of that variable.
Okay, I gotcha.
So if I use anything else, the answer will still be the same. But if I use base A, then I have an additional factor in there in the denominator. It's a constant. It doesn't matter, but I cannot forget that.
Gotcha.
So
okay.
the easiest is natural log, but you can apply any log you want, as long as you apply the same log to both sides. So if A equals B, you cannot say the log base 5 of A equals log base 6 of B. That's not possible. So as long as you apply to both sides the same log, you're fine. Good. Anything else? How do we feel about this? Can we continue? Any questions? Anything you have for me, anyone? Okay, well, let's continue then with applications. Three point 7. And we have a lot of applications. Let's start with something that we've done many times before. So I'm looking at a problem like this. A particle moves with position function, blah, blah, blah. At what time does the particle have a velocity of this? And what time is the acceleration 0? What is the significance of this value? Something like that. If a ball is thrown vertically upward with a velocity of this and this, what is the maximum height, so on and so forth. So this is just a basic type of application first. And then we can branch off from there. These are the problems I'm looking at. So let's start with that, the one that we just read. Feel free to choose. I have my WebAssign brought up, so it's waiting for me if any moment you want to choose. So S of t is a particle, the position function, which is t to the fourth minus 4t cubed minus 20t squared plus 20t, and t, of course. Oh, I'm sorry. Did you finish this? Can I move it? I'm sorry, I forgot to ask. Did you still need me to keep this up?
I think we're good.
Okay. Good. So our first question here is, at what time does the particle have a velocity of 20 meters per second? Part A, time for velocity 20 meters per second. Okay. What do you think we have to do in this situation? We are given the distance formula, or position function if you want. Position function. We are told that obviously we are talking about meters per second, so the distance is measured in meters and the time is measured in seconds.
We need to take the derivative of it.
Very good, because the velocity of t is definitely the first derivative of the distance function or position function. Very good. Can anyone help with that?
It's going to be 4t to the third minus 12t to the second minus 40t plus 20.
That's it. Okay, and now they're asking us to find the time when the velocity is 20 meters per second. What do we need to do?
Equal the equation to 20.
Very good. So V of t equals 20. Thank you. Good. So then I have 4t cubed minus 12t squared minus 40t plus 20 equals 20. Any suggestions for the next step? Let's say
the 20 over to the right and make it 0.
good. Next. What do you think?
Factor out a t.
Good. So 4t squared minus 12t minus 40 equals 0. So from here, using the zero product principle, we have two options for now. So let's say, Mickey, what do you think?
You could factor out a 4.
Right, so what are
As
the
well.
first two options, first of all?
Positive or negative?
T equals 0 and the stuff with the parentheses equals 0.
For the first option, t equals 0, and the second option, 4t squared minus 12t minus 40 equals 0. Yes, of course, I will divide both sides by 4. And I have t squared minus 3t minus 10 equals 0. What will be the next step? Let's say, Lindsay, would you like to tell us what would you do on this next step?
Factor it into
Great job.
t minus 5.
Very good. Good. So then we have two more options. What are they?
Five and negative 2.
Very good. So basically, we only have two possibilities. Obviously, time is positive, and we are also told it's positive or 0. So there are only two possibilities, t equals 0 seconds and t equals 5 seconds, when the velocity v of 0 equals v of 5 equals 20 meters per second. Part B, at what time is the acceleration 0? At what time is the acceleration 0? That's part B. At what time is acceleration 0? How do I determine the acceleration?
You need to take the derivative of the previous derivative.
Right. Acceleration is the first derivative of the velocity or the second derivative of the position or distance function. Perfect. So I have the velocity. I have to differentiate this one more time. Can anyone give us the step that I need to write for a of t?
It's going to be
12t to the second.
Very good, excellent. Minus?
24t
Minus?
40.
That's it, awesome. I don't need that anymore. Good. So they want us to determine the time when the acceleration is 0. So what do? Of course, I'm going to do what?
Set the equation equal to 0.
Very good. And yes, of course, I will divide by 4. And I get a 3 here. I get a 6 here and a 10 here. We can use the quadratic formula. Let's see, this is negative 30 and a negative 6. If we can factor in 10 seconds, fine. If not, forget it. Negative b plus or minus b squared minus 4ac, but this is negative. 4 times 3 is 12, 120. I change the sign over 2a. I want to show you, I'm sure you do know, but maybe not everyone. Let me show you, I'm sharing the screen. And here's how I recommend you enter it. So, left parenthesis, 6 plus the square root. Where is my square root? Over there. Okay. I always put parentheses. Newer calculators don't need parentheses. Here, 36 plus 120. Close the parenthesis, go outside and close another parenthesis for the numerator, and divide everything by 6. Then go with second and entry. It copies everything, and just go to the left and override plus into minus. And you get your answers right away. Any questions on this? So you don't have to type it up again.
I have a question. How many decimal places do you?
It's a very good point. It depends, really. If we talk about money, we never use more than 2 decimals. If we talk about velocity and acceleration, I guess 2 decimals are fine. When we get to Newton's method in chapter 4, I will say 6 or 8 or whatever it's mentioned, right? But in general, 2 for exponential functions like exponential growth, exponential decay. If it's a rate, I recommend 4 decimal digits. But in general, 2, unless otherwise specified. It's a very good point. Okay? So I'm going to copy t equals, but when we talk about seconds, 3.08 will be enough. If you want to say 3.082, that's fine too. 3 decimal digits. The other one I'm going to copy, but I'm going to erase right away. So we have it algebraically. This is a correct solution, but not for what we are discussing here. Any questions? Okay, this is a very interesting type of problem that I would like to discuss with you. If a tank holds 5,000 gallons of water, which drains from the bottom of the tank. I'm sure the problem is in the book. I don't think they removed this problem. It's an interesting problem. Which drains from the bottom of the tank in 40 minutes. Then Torricelli's law gives the volume V of water remaining in the tank after t minutes, and I'm going to copy that for you. And we are going to answer the questions. So we have the volume function V of t equals 5,000 and 1 minus, I think it's 1 over 40, t, everything squared. And the time is between 0 minutes and 40 minutes. And the volume is in gallons. First question, find the rate at which water is draining from the tank after 5 minutes, 10 minutes, 20 minutes, 40 minutes. So what is the rate of change of volume with respect to time? How do I determine that? Rate of change of volume with respect to, that's how lazy people write, with respect to time. What is that? What does it mean? Anyone? So once again, we are asked to find the rate at which water is draining from the tank after 5, 10, 20, and 40 minutes.
It's going to be like gallons a minute.
Right. So how do I determine that? Because if I don't have a function to plug this in, then I will not be able to determine the rate of change.
This is just the derivative of the
Of course. Yes. So let's write the derivative. V prime of t. Can anyone get us started? Javon, Kush, Isaac, anyone? Josh?
5,000.
You mean 10,000, right?
Oh yeah, 10,000.
Good. And then?
Would be the 1 minus 1/40 t.
Times the inner function prime.
-1/40.
Great job. Thank you. So then I will continue. Try to simplify a little bit if I can. So I will simplify. First of all, I have a minus in front. 10,000 divided by 10 is 1,000. And then 1,000 divided by 2 is 500 by 2, so this must be 250. And then 1 minus 1/40t. You can distribute if you want. It's up to you. Or just leave it alone. So let's put this function in. I'm going to share my screen. Go to y equals. Clear if you have anything else in there. And enter -250. Open a parenthesis, 1 minus. Careful how you enter this. I recommend 1 divided by 40. Close the parenthesis. Of course, x, I don't have t, and close. If you don't put 1/40 in parentheses, it may consider 1/40x and 40x in the denominator. I don't know. So be very careful. So now, go to second and table. I'm going to quickly enter 5, 10, 20, and 40. When I click on 40, what should happen?
Error.
Yes, no, it should be 0 because we are told that it empties out in 40 minutes. But it was difficult for you because you don't see the text in front of you. So I know for sure that that would have been very easy if you had that. So here's what I'm going to do. I'm going to create a table like we always do to summarize our information. V prime of t for 5, and we got, please always go back and highlight to make sure that you see the entire number. Okay, so the first one is -218.75 for 10 minutes. Highlight, please. -187.50 for 20 minutes is -125, and of course for 40 is 0. I'm going to stop sharing now. Okay, so here's our table. So of course this is in minutes, and this is the rate of change. All these numbers have what measurement unit?
Is a gallon.